Okay, now recording. So, what is your question?
So when we install Unity on here, we saved it on here. Is it saved to the computer or like a Unity profile?
Unity projects do not get saved to your Unity profile. It probably does some kind of cloud storage that you have to pay for, not by default. You can set it up. You can set up a Git repository or a GitHub repository in order to, like, save a Unity project. That is actually a fantastic thing to know how to do, but with respect to these lab computers, you should assume that anything that gets put on them gets wiped overnight, because that is the case with many of them, but not all of them, but you should just assume that as a rule. So keep an external drive and keep your work on that. Yeah, which I think I said that at the beginning, didn't I? This is not an external drive, this is a battery. This will not help you. So, maybe later. So, does it remember me? No. Sign in. Server is currently unresponsive. I don't like the sound of that. Let's see if it'll just let me do it anyway. Okay, so are you folks having trouble with Unity in any way? No? Okay. Please, if you haven't done so already, create a new 3D Unity project. How's that? Is that good? I really like this classroom. Like, the number of options I have here, just here, you know? Like, if I wanted to do linear grading on the lights, I could do linear. If I wanted to do like an exponential function, or a, you know, exponential decay, something like that, I could do all of that. It's all available to me. Fantastic. So, so while Unity figures itself out, this is what this week is looking like, all right? The assessment for this week will be a lab exercise. We will be performing the lab exercise during our Friday session. This will be a procedure that you will follow to do some things in Unity. You will produce a project that, you know, performs certain operations. You will package that up, submit it to me on Canvas, in addition to a short write-up about your project, what works, what doesn't, what you would do better next time, you know. Yeah. Don't put a whole lot of effort into your reflection, please. A couple of paragraphs is more than sufficient. I'm not going to read a novel. I like you guys, but I'm not going to read your novels. Just, you know, some screenshots of what you did should be in there as well. It'll all become clear once you see the actual lab description. But the intention with the lab is that the programming portion will be done in class. You are free to write the reflection later as homework, or if you finish it early in class, you can work on the reflection in class. Does that make sense?
When is it due? When does that start?
I will make it due 1 week from the day that you start working on it, which I think is fair.
Which is when exactly will that be?
So it will be due, we will start performing it 8 a.m. this Friday. It will be due, let's say, midnight Thursday of the following week, of next week. Sound good?
Okay.
Any complaints? No? Good. Nobody's going to complain to my supervisor? Okay. Good. I love it when the agent doesn't get complaints about me. So let's think a little bit about objects in Unity. Pardon me. So one of the things which we demonstrated in the last class was the ability to modify the color of a solid in Unity, right? Let us now see how we would make the same modification in code. Okay? Because when you script something like that, you can have something change dynamically based on some inputs, right? So, for example, what qualifies as input here can vary. It might be a user interaction, such as clicking on an object. So, the object can be, green to start. When you click on it, it turns red, something like that. Another input could be time. The color changes as time increases. Something like that. So, shall we get started? In order to modify the color of a solid, we first need a solid to modify the color of. Hopefully everybody remembers how to do this in Unity. How do you insert a solid in Unity? Yeah. You say game object, 3D object, and then you have your list here. Please select cube, sphere, capsule, or cylinder, whatever is most appealing to you at this point in time. I'm going to pick capsule. Capsules are fun. There is a capsule. So, oh, by the way, this background, which is presented using the default view in Unity, this is like a very, very basic skybox that it adds by default. You actually have the ability to modify what this skybox is. You can use a proper skybox, but for our purposes, you can just set this to a plain gray background or some solid color. I will show you how to do that now. The skybox is a property of the main camera. So if you select the main camera object, take a look at the camera game component, you will notice that you have skybox, perspective, vertical, all these types of options. Incidentally, if you want to put things in orthographic mode, that's also possible from the camera. That basically turns off perspective in the same way that we were doing with the, clicking the middle of the widget here, right? That difference, perspective. This is perspective, This is non-perspective. You can get the same thing with the main camera using projection, orthographic versus perspective. I'm going to choose orthographic because why not? Under the first, clear flags. Skybox, solid color, depth only, and don't clear. So solid color allows you to pick some background color. Does not imply the existence of a three-dimensional space, but hopefully the existence of the three-dimensional object implies the three-dimensional space. Right? So I can't really show you what don't clear does because we don't have any like movement yet. But has anybody seen a video game that glitches out and it's like you get repeated images of like the player character in the background, right? Have you've seen that kind of glitch? Basically, that's what don't clear would do here. You would get like, because it's clearing the page and putting in the solid color every frame, right? Anyway, so there you have it, solid color. So, in order to make this capsule colored, does anybody remember what we did? Yes. We have to create a material. Very good. Do you remember how we do that? And by the way, please speak up because that is a pretty loud HVAC system in this room. That's like the one bad thing about this room. It's loud in here.
There's assets at the top.
Assets? Create.
And texture.
Right there?
Yes, that's the.
Yes. You can access the same menu by right-clicking inside of the Assets pane. So, the name is not important. Not important. There we go. We can modify the properties of our not important material. Let's make it a nice blue, a nice royal blue. And we can apply this material. Last time I showed you the method by clicking and dragging it on. However, there is another way of doing things that I'd like to show you because it's useful. So, if you take a look at the mesh renderer component, it will have a materials drop down, and here it will specify default material, which is a Unity default object. If you click the little target thing, it will filter all of the assets in your Unity project for only those that could be correctly placed here. So, if you can also search for the particular asset name that you're looking for using your keyboard skills. So, it's easy enough when your project only contains one material, and it's a simple example. But let's imagine that your project contained 500,000 materials. It would be kind of hard to pick through them all. So, there we have it. We now have a nice blue capsule in my case, and whatever color you picked, and whatever solid you picked in your case. So, the next question we must ask ourselves is, do we remember how to attach a script to an object in Unity? You remember how to attach a script? Add component. Good start. Now, new script. Specify the name of the script. Let's call this color change. Oh? Not working, you say? Go to projects. New? Yep, quick. 3D, create. And it should take, it will take a moment, but it should go there anyways. No trouble. Anybody else need some assistance? We good so far? Cool. So, color change script, create and add. You will notice that the script has been included as a script file, a .cs file right here. And we want to edit it. So you can double click on it. That'll open Microsoft Visual Studio, which has been linked in this instance of Unity as the default editor. If you are using Unity on your own personal device, it is possible a different editor will be launched automatically. My opinion is that the editor doesn't matter that much. What matters is the stuff that you code. So yeah, it is useful to have the libraries autocomplete for you, to be able to like tab through all of your options, as we shall see. I don't care what's new. Doesn't it kind of undermine the idea of that there's something new when it's telling you there's something new every single time you open it? Like, shouldn't something that's new be something that's like novel, something that doesn't appear all the time, you know? I might pay more attention to it if it didn't shove it at me constantly, you know? All right, double click on it again, I guess. There we go, now it's open. So, quick recap. What does this thing do? Don't read the comment.
It's what the script that's read as soon as you start the game.
Yes. So, any code that you put in here is run not on game start, actually. It's run on object creation. So, so far, we have not, like all objects have been created at the same time the game starts. But that's not necessarily the case. So, for example, if we were to do a little Space Invaders type thing with like little angry guys and a little spaceship shooting bullets, the bullet itself does not exist when we start the scene. It comes into existence when we press the fire button. Once it hits an enemy and explodes them, it will wink out of existence and be destroyed. But this thing, its start method, will be called when the bullet object is created, i.e., when the player presses the space bar, if that's the fire button. Does that make sense? A little bit? Tiny bit, hopefully? You'll get the hang of it, don't worry. How about the update method? Yes?
Not exactly sure, so I'm just gonna guess, but I think that one runs like every couple of seconds.
So not every couple of seconds, but 60 times per second.
Oh, right.
Yes. Once per frame of the game. So somewhere between one frame rendering and the next frame rendering, the script will execute between each of them. Good. So roughly speaking, if you want one-time behavior that happens at the start, you use the start method. If you want repetitious behavior that happens many times, you use the update method. Pardon me. So, okay, things are about to get a little bit tricky. So, we are trying to modify the color property of the material which is attached to this game object. In order to do that, we need to access a reference to that property. This means that we need to descend through the hierarchy of script objects to find the thing we're looking for. So, all of these components that we see in a Unity object, right? Everything here has a counterpart in the scripting. Each one of these properties is accessible. All of these items, like some of these items, are sub-instances of other items. So, for example, the materials, you notice that it has like this kind of interface, and you can add and subtract elements here, right? This is a type of structure we call an array or list. So we can have multiple here. We're only concerned with that one. At some point, we're going to have to select them. This here, not important, is an instance referencing this guy down here. We are going to have to modify properties of this instance. So, we're starting to get into a little bit of object-oriented programming. Okay. Already, I know. It's terrible. I wish it wasn't the case, but this is kind of how you have to do anything in Unity, so please just try to bear with me. So, let us start with this. This keyword, when used in a script, this word, this, and I know it's horrible to say because I'm having to say the name of the thing I'm referring to using the word in other parts of the sentence, but this means it means a reference to this script, which is an object, or it is a class. So color change is a class. This is a reference to the object that is attached to the game object. So, in object-oriented programming, you access sub-instances or things attached to an object using dot syntax. So if I want the properties of this, I hit the period key. And you can see that this lovely little context menu brings up a whole host of different things. These are all properties and actions which may be performed on this. This being the reference to the script itself. With me so far? Okay? Okay. Some of these are fairly simple. Something like enable. Oh, I'm going to turn off you autocomplete. Every single time I have to do this. There we go. So, enabled equals false does exactly what you might think it does. It disables the script. Right? If we save that and we run it, there we go. Clicking on the capsule, notice that the little checkbox here is unchecked. Right? These little checkboxes indicate whether the component is enabled. So you can see that our little line of code has disabled the script. We have modified a property of the script. Note, we have modified a property of the script only, not the game component. Does that make sense? So far, so good? Okay. If this does not make sense, please, please, please ask a question, because you're probably not the only person in the room that has the question. Yes?
So this statement pretty much just means like this is what happens in this script. This is what I'll allow in the scripts.
Yeah, so when I use this inside of the script, this is bound to that, right? Just this component and just attached, yeah, sorry, it's a little low on the screen. Just this component and only attached to this game object. It does not apply globally to all scripts. So you have to think of this here, as an instance of this code that we've written.
So it's just specific to that object we're using this thing to.
Yes, it's specific to this object. However, because we've coded it the way that we have, if we apply this script to any other objects, it will still run that code and disable itself. Question?
How do you apply the code without dragging and dropping?
Oh, here, I'll just, I'll apply it to main camera. Add components, scripts, and it gives you a list of them. So you can do it pretty easily. You can also, let me just remove that. You can also drag and drop into your list of components, which is probably the easiest one. I don't know if you can drag and drop onto objects. Can you drop in, like, here? Does that work? Probably not. Yes, it does. Actually, look. Whoop. There it goes. Remove. There we go. All right. So, all right. So this refers to the script. Okay. The script only contains what we see in the code here, right? In terms of the object hierarchy, it doesn't have any subcomponents. So if it has 0 subcomponents, it obviously doesn't contain the mesh renderer. So it doesn't contain the thing we want to modify. This is kind of how it works, right? You have the game object up here, right? It contains as a subcomponent, what did I call this script? Color change? Color change, change.cs. It also contains the mesh renderer. So, in order to get to the mesh renderer from my script, I have to go back up the hierarchy to the game object and then come back down to access one of the components of the game object. Does that make sense? I can't get there directly. There's no link from here to here. I have to go up the hierarchy and then back down again. So here's the way that you do that. This dot game object, let me get it so that the auto completes. This dot game object, lowercase, because uppercase is the type, game object. Let's see. Game object dot I think active is the same thing as enabled in game objects. Let's see here. You can see you can get things like the name of the game object. You know, you can acquire that property and use it in your calculations. Let's see, active, there we go. Game object active. Obsolete. Set active. Oh, yeah, okay. So in this case, they don't want you to modify the property directly, they want you to go through a method. But this is a good introduction to methods. So where you see the little cubes, the little purple cubes, these are actions. These are methods rather than the wrenches, which are properties. So if we want to set this game object to be inactive, we set active false. Now, this is a very helpful pop-up. When you are using a method in Visual Studio for Unity, if you just hover your cursor inside of the braces here, it will give you a description of what type it expects you to input. So in this case, it's expecting you to input a Boolean, true or false, right? So set active true, you can imagine that sets it as an active game object. Set active false disables it. So, set active false. Does anybody want to guess what this line of code will do in the game? What will we see? Yes? Let's test that theory. Which is my way of saying yes. Boop. And it's gone. Now, it's important to understand the game object still exists. It hasn't been destroyed. It's being disabled. You can see our little is it enabled checkbox has been checked off there. We can bring it in, bring it out, bring it in, bring it out, bring it in, bring it out. In, out, in, out. So, sidebar. If you want to destroy the object entirely, this is how you do it. Destroy this .game object. If you execute that line of code, you'll notice that it no longer even appears in the game object hierarchy. It's been removed from memory. Does that make sense? Any questions about that? Yes?
They don't work with you, they call it change state.
Can I see the code? Show me your Unity game. Show me the Unity. It's disabled. Yeah. Oh, wait, is this saved? The little asterisk here means that it's not saved. Yes.
So for this set active false, does it just hide the object, or does it just appear from the scene and still in the essence?
So set active false, it does a little more than hide it. It also no longer performs any calculations on it, right? A script on a disabled game object won't execute, right? So that's different from just hiding it visually, which is equivalent to disabling the mesh renderer, right? It's not that you're not rendering it, it's that you're not doing anything with it. And it can't turn itself back on with the script. Yeah. Because the script with which it would turn itself back on is disabled, because everything's disabled. Logic. Question?
Mine's
Oh, well, the script isn't actually attached to an object, so that's the first thing. There we go. Try her again. No trouble. Remember that changes that you make in play mode are undone when you exit play mode. That's the most common reason that sort of thing happens. Okay. So, we started here, we went up here, now it's time to go down to here. The method that we use to acquire a child object, this is what this is called, is a child object, is get component with the angle braces. Get component. Inside of the angle braces, we have to specify the type of the component that we want to target. You'll notice that game objects have several different components. You have to say which one you're after. So, in this case, we are after a mesh renderer. This is technically called a generic, but we do not study them in this class. It is a form of type polymorphism. You must include the round braces after the angle braces because this is still a method accepting no arguments. Now, if we hit dot enabled equals false, let's see what we turn off. We have turned off the game object, but you can see that the capsule object not only still exists in the game hierarchy, it's not been grayed out. The object is still active. The only thing we turned off was the mesh renderer. So it's no longer showing up because it's no longer rendering, but it's still there, the script is still running. Make sense? Good. Question? The material? The material is used to okay. So, have you done any 3D modeling at all ever in your life?
I use SolidWorks.
Okay, so it's the difference. It's roughly the difference between your wireframe and like the image that you're overlaying on the wireframe. The wireframe itself tells you when like rendering rays intersect the geometry, right? When you need to color a pixel, but the material tells you what color the pixel should be once it's been determined that you need to render it. Does that make sense? Yeah, the mesh is the skeleton, and the material is the skin. Yes. I mean, it is significantly more complicated than that, but that's a sufficient understanding to do what we're doing. So, okay, we're making progress. So, of the mesh renderer, let's take a look at the properties that the mesh renderer has. So, we have material and materials. The hint for this is that the name will be the same as it appears in the inspector. Here, we have an option though. materials gives you the entire array, but material, singular, returns just the first one. You remember how I said in Unity, in the inspector, like we could add more here? Oop. There we go. That's the material. We could add, oh, I did it twice. We could add additional materials here or get rid of them. If you just want the first one, just use material singular. If you want the whole array of these, use materials plural. In our case, material singular is what we want. So, this will return a reference to the material that is attached to the mesh renderer. Let's see if we have any properties here. Oh, look at number 2. That's the thing we're looking for. But just to prove that this is, doesn't look like we're going to get an easy turn on, turn off. Sure. Okay, so we have finally found the property that we are looking for. GameObject, this.GameObject.getComponent meshrenderer.material.color. We have found it. So now we need to set it. And I think that we just use assignment. Okay. The question is, what are we going to assign it to? Because we can't just say red. But we can say color dot. So let's just leave that as it is for a moment. The purpose of classes and objects is to provide a standardized interface to be able to modify things. When we get into physics properties, we will be talking and position and that sort of thing. We will be using the vector 3 object, which represents a vector in 3-dimensional space. Here, we want to view properties of a color. We want to modify colors in some way. The color type, the color class, provides many useful methods and definitions which we can use here. Color C is equal to new color. What I have done here is I have declared a new color object named C, which essentially functions as a variable. It's a variable of type color. It has all of the definitions in the color class. You can use its methods, you can use its properties, but it's not attached to anything except inside the script. It only exists here where it's been declared, right? It only travels outside the script if you tell it to. So, C dot, and you can get all of the interesting properties of this object. So, when we declare a new color, we are using the constructor of the color class. This is called the constructor. If we provide values to the constructor, we get different behaviors. Quick hint, if you delete the round braces and put one in, you put one in, there you go, you get different definitions, if you click through the arrows, of how colors can be instantiated. Let's look at this one. Color, taking a float R, a float G, and a float B, constructs a new color given RGB components and sets A to 1. So A means alpha. Alpha means transparency. These are floats, and if you look in the documentation, it's expecting a number between 0 and 1. Right? So you guys know like red, blue, green color components in like monitors and that sort of thing. Is this a foreign concept? No? Okay. If anybody wants me to go through that, I will happily do so. You'd like me to? Yeah, sure. I even have red, green, and blue. So, this is the way that monitors work, right? If you take a look at any pixel, any particular pixel in a display, it has 3 components. Every pixel is actually it's actually 3 colors, and I think the modern way to do this is to include, like, I know it's black, but it's white. It's like a brightness one, you know. So in an LED screen, you will have these tiny little LEDs, like very, very small, all crammed together. And if you look really, really, really closely at your screen, sometimes you can see them, but it's very, very difficult because they're almost microscopic, right? So the idea is each one of these pixels shines with a particular intensity, right? That intensity, you know, if 1 is the maximum intensity and 0 is off, you can represent a pixel using 3 numbers, R, B, and G channels, right? So if you're remembering elementary school and you're like, well, like I know color mixing is a thing, but I thought it was red, blue, and yellow that you can mix to make all of the different colors. That is a subtractive color mixing, which works with pigments, but it doesn't work with light. I think it's called subtractive. Under additive color, this is how light works when you're like working with the wavelengths directly, right? So, somewhat counterintuitively, if you combine red and green, you get yellow. If you combine blue and red, you get magenta. And if you combine blue and green, you get cyan. That's yellow, magenta, and cyan. And do you have a printer that takes ink?
I don't have.
Yeah. Anybody have a printer that requires printer ink? Yeah. What are the colors that what are the colors that your color ink tank uses?
It's the yellow, magenta, and cyan.
Yeah, because you can sort of mix these together, and this is kind of you're able to like, you know, work your way back to the RGB of the screen, which is theoretically what you're supposed to be printing, right? So basically, if we turn the red channel up full and we leave these 2 off, we get red. If we turn on green and red, we get yellow, etc. And every color can be represented as some combination of these 3. Does that make sense? Where if you turn them all on, you get white. Question? No. You gotta be careful with those hands in this classroom. You know, I'm quick. You better have a question. I'm kidding. So if you wanted to define a nice, custom color, you could say something like, well, let's do 0.8 red, 0.3 green, and 0.1 blue. Normally, any color that you come up with this way will be ugly. But, I'm not teaching you how to make something beautiful. I'm trying to teach you programming. So, this is all well and good, but as you may notice, I have once again been attacked by the red squiggles. So, when you are attacked by the red squiggles, the thing that you should do is hover your cursor over the squiggle, and it will tell you what the corresponding error message is. Now, you may not know what that error message means, but at least you can read it. Argument 2 cannot convert from double to float. So this is kind of a silly thing, actually. You'll notice that the color object requires 3 floats. Don't ask me why. It's one of my personal pet peeves. But literals of this type are by default doubles, not floats. While they are both floating point numbers, they do not convert to each other nicely. So the thing that you have to do, and it's stupid, don't ask me why, but you have to do it, you have to put a little F after each of your numbers. That tells the compiler that you mean floats and not doubles, and then it's happy. So, now that we've done all of that, let us take our newly created color object and assign it to the material color of our mesh renderer's material object attached to our game component, which is attached to the game component that the script is attached to, working our way back through the chain. Let's run it. And actually it's not too bad. That's not a completely ugly shade of orange. It's like moderately ugly orange. So there you go. That's how you modify the color. Question?
When you typically would do this in a game, would you use like a chart that tells you what numbers to use for specific colors?
Well, if the specific color you want is specific enough, the color object actually contains a few pre-built definitions. So if you say color dot black, blue, clear, cyan, gray, green, gray with an E instead of an A, magenta, red, white, yellow. If you want any of those colors, which are really just like, full blast channel versions of each of these colors, they are pre-built, so you can use those. But I wanted to show you this as lessons and stuff. That's the easy way to do it. Yes?
Do you know why it's the letter F?
F for float.
Oh, makes sense.
Yes?
So why would you script color change instead of scripted material change?
Watch this. The question is, why on earth would you ever want to do this? Fair enough. Watch this. Floats R is equal to, no. Declare them up here. Public floats R is equal to 0.0 F. Public float G is equal to 0.0 F. F's in the chat, folks. Public float G is 0.0 F. Move that to our update. Replace these with R, G, and B. There we go. Run it. You can see that 0, 0, 0 gives you black, or like charcoal, I guess. Once it does the lighting effects, it kind of takes out some of the blackness. But you will notice on your object that you now have R, B, and G components, which you can slide. So that's why you would want to do this in a script. Because these slidings that I'm doing, I don't have to do it through the inspector. I can also hook that up to the script. For example, you got this is a little bit beyond you guys at the moment, but I'm going to do it anyway just to show you. All right. So for example, R is equal to R plus 0. Well, actually, this should be fine. 0, 1, mod 1. F. So what's this going to do? Every frame, it adds 0.01 to the value of F. Mod 1 means anytime it exceeds 1, it'll knock it back down to 0. So if this here would put it over 1, it'll blank the channel back out again. You remember how I was saying that you could do a sawtooth wave with modulos? Check your, yeah, there you go. Ta-da! And that's all from script. So yeah, you can do fun stuff with it. Question?
Would this hypothetically also be useful for things like character customization and stuff like that? Or would you use new material for character customization?
Absolutely, you could use this for character customization. What you would do, like, if you want to make a component that you can modify in this way, what you would do is, like, in the modeling software, you would make it gray, right? And then, because like, the color component on the renderer here, it's basically just like applying a blanket color over whatever texture it's been given. So if you have a texture, but it's in grayscale, you can modify the color of that object using this, and that's, yeah, this is exactly the sort of, this is the thing that allows you to pick whatever shirt color you want, basically. Yeah. Any questions? Okay. All right. Because I'm the professor and I am invested with certain powers, I declare there to be a 5-minute break. We will resume class in 5 minutes. Okay? So, if you Google image search grayscale texture of, yeah, wood is fine, grayscale wood texture, you'll find that there are all kinds of these things with and without Shutterstock photo things on. But, you know, this one's kind of nice. Except it's got that. That's fine. So if you save the image, well, maybe I should find one that's PNG. There we go. Sure. not a PNG, but it'll do. Wood grain texture, just call it wood. There we go. You can import outside resources into your Unity project relatively easily. Click and drag. There it is. Don't worry about that. Now, this is your, so you want texture type, yeah, I think default will be fine. If you go into, rendering mode, is it not rendering mode? No, oh man, I'm forgetting how to do it. Oh no, here it is. I think that's detail albedo, but these things are actually like calling for a texture. There you go. The wood grain texture applies to the object. So you can throw these here, these little boxes. They look like checkboxes, but they're actually requests for images. So you can use it as a albedo, which has this effect. None, back to none. If you do occlusion, it's darker. Normal map, you can see that that's interesting. What a normal map does is it applies like a bumped surface to it. If you combine that with the albedo, it looks quite a bit more like that. Normal map, maybe we can like turn this up. You know, you can play with the settings. Height map, there you go. That does. No, I'm sorry. Height map is the one that makes it raised. You can kind of see along the edges a little bit. It's still very. Maybe I can just. Anyway, that's all fun stuff that you can play with. I'm not gonna require any of that from you, but yeah, I just thought you might be interested in that. Ooh, metallic wood grain. Love it. That's wood isn't really smooth, so it should be smooth here. There we go. All right. So. What am I going to do next? Something else. How about timing? So, I kind of did a slight introduction to this concept here, using our R value. Here, you keep standing up, I'm sorry.
That's fine.
I'm scared. Is that better?
Thanks.
So, we've seen variables in the C# when we do this, like the pure C# scripting that we've done. We've been using variables. We haven't really seen what they're good for yet. We've been using them to perform calculations, but they're still somewhat facile. The variables here hold data between calls to a method. So here, what this is a somewhat sophisticated form of counter. But there are simpler forms of counters that you can have. For example, if I wanted a counter that simply counted the number of frames that have occurred since the game started, how would I do it? Anybody have any ideas? Yes?
Set a variable and just put essentially like say the variable is y, just put y or y plus plus in the void update.
Yep. We will need to initialize it. So you can either initialize it here or you can do it in start. I'm going to do it in start just for variety. Technically that initializes them at different times, but not in a meaningful way. Y plus plus. Y plus plus is precisely equal to y is equal to y plus 1. It's simply an abbreviation. Does this make sense? So, I might recommend picking a slightly more informative variable name, such as frame count. That way, when we go to the Unity editor and take a look at our variables, sorry, I can't pull that up any further. It's right here. Frame count appears, it is 0. When I run the program, you can see that frame count is increasing at a rate of 60 frames, or 60 per second. This is useful for determining how much time has elapsed since something starts. So, for example, if I wanted to say, I want something to happen 5 seconds after after this thing starts, or 5 seconds after some kind of condition is met. This is one way of counting how to do that. Does that make sense? Good. It is not the most precise way of doing so. So, it does not solve for the problem of inconsistent frame rates. As we all know, 60 frames per second is a goal, and that goal is not always met by video game applications. I'm looking at you, Pokemon games on the 3DS, especially in 3D mode. So, this count here may not necessarily reflect reality. When you say, okay, this number divided by 60, that's how many seconds have elapsed, that is assuming that every frame went perfectly. That is not always the case. Fortunately, Unity keeps track of data, which allows you to know this with precision. So instead of saying, so frame count is fine because that's actually what we're counting is the number of frames. But let's say public float time elapsed. Set that equal to 0. We still wish to modify this in the same way that we are modifying our frame count. But in this case, we want to add something to it other than 1. We want to add the amount of time that's passed between this frame and the last frame. Quick note, plus equals is the same as, so x plus equals 1 is the same thing as saying x plus plus, which is also the same thing as saying x is equal to x plus 1. Time is a class. You can see it's derived from the Unity engine, so you know it's keeping track of important things. Many properties, time dot delta time, most particularly delta time. The interval in seconds from the last frame to the current one, read only, returns a float. So it returns a float, which is the number of seconds that have elapsed, but of course it's going to return a small decimal, approximately 1 divided by 60 each time, right? But not completely consistently. For example, if I just comment this out for a moment, if we say debug.log time dot delta time, let's just see what it looks like as it's run. So that is much less consistent than you would hope, right? You can see we're sometimes even modifying this digit here with a 1. Now this is probably because these computers are, I don't think they are GPU accelerated. I know mine is a thin client. Or is it a thin client? I don't know. It looks like it's a thin client. So, yeah, it's a thin client. Yours, you have like the towers that you're sitting on, so I don't know, maybe they crammed GPUs in there, probably not, they're expensive. If you had a GPU, you would get a more consistent frame rate because you'd be able to perform the calculations faster. But you can see that that's actually quite inconsistent, right? So, number of elapsed seconds is equal to time plus time delta. There you go. Okay, brief digression. Is anybody curious what all these publics mean? Does anybody care to guess what that means? Yes?
Would it mean that essentially like every class would use them? It's like public for all classes?
Yes. So when you make a property public, it means that other pieces of code can use them. It also makes it so that it's visible in the inspector. If you made one of these private and public, those are the two opposite sides of the coin. If you made one of these private, that element disappears in the panel view. It's now hidden. So you can think like it gets a little bit more complicated than this once we get into more object-oriented programming, but for now, public means visible, private means hidden. Make sense? Okay. Good. So if we wanted something to happen based on the time elapsed, we can use our old friend, or perhaps our new friend, the if statement. If time elapsed is greater than 5, modify the R channel. Otherwise, modify the blue channel. run this, 1, 2, 3, 4, 5. There you go. Now, it just so happens that at 5 seconds when this thing stops, the blue channel is almost on full, so it's like rotating between blue and magenta by modifying the red channel. If you modify this this condition here slightly, you'll get a different outcome. That's more of a pure red. Does that make sense? See what's going on here? So, any questions about that? Okay. So, let's now talk about click events. Okay? So, there are basically two ways to approach click events. There is an input object, which you can use in code. Input. This allows you to get keyboard key presses, mouse presses, things of this nature. But input is global to the entire application. So if you want the fact that the screen was clicked, you can go through input and get its mouse event. If you are concerned, however, with the individual object that you're, like our capsule, whatever your solid is, if you want to know if that thing was clicked on, then we use a new method. On click. I think on mouse down. That's the one. I think. Or maybe not. Am I going to have to consult the documentation? I'm going to have to consult the documentation. Okay, this is how you consult the documentation. Go to Google, on, mouse, down, event, Unity. It should say scripting API. If it's mono behavior, then that's the that's a method that you can use in the same place as start or update. So here we have void on mouse down. In this example, we are destroying the game object after clicking on it. But we're going to do something different with it. So, but we can start, that's actually a decent place to start. So, void on mouse down. Destroy this .game object. Like that. Question?
How do you disable that autofill?
There's a little gear icon that appears above the gray text. If you click on that, you can uncheck the checkboxes. So, save. Let's load up Unity. And click! Kaboom! It is destroyed. If I click somewhere else, it doesn't work. If I click here, it's dead. There you go. And of course, you can say something like private void. Oh, I probably haven't explained what void means. Void just means no type. Technically, no type is a type, but if it's not an integer, it's not a float, it's not a Boolean, it's not any class, it's void. It's another way to say this method or function returns nothing. On destroy. Debug.log. Goodbye, cruel world. There you go. Save. So, if we run this, click, the object is destroyed. When it is destroyed, it runs its onDestroy method. Goodbye, cruel world. Question? It's not there because interface is not what we want. Sure. Oh. There you go.
Spelling. Spelling counts.
Good, 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 good. 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 Awesome. Okay. So, that's all fun. Would you like to see how to do a little bit of positional control now? You know, something approximating a video game. So, the input object contains contains methods which allow you to read the state of the keyboard. So, if input dot get key, we have some options. Get key down, and get key up. Get key down activates on the first frame in which a button has been pressed. Get key up activates in the first frame that that button is released. Get key is true so long as the button is held down. In our case, that's the one that we want. Get key, we now have to specify which key we want. Key code dot, and then you have the options of all of the keys on the keyboard. In our case, let's do the left arrow. Now, we want to modify the transform of this game object to reflect some movement. This is the basic way of doing it that avoids having to interact with the physics engine. There are better ways of doing this if you are modeling the object as a physics object. If you are doing anything complicated, you will probably want to model it as a physics object. But this is the basic version that will just get something moving on the board. So, this dot transform is how you access the transform object. This is a shortcut. This is a shortcut that does this dot game object dot get component transform. You do that often enough that it just allows you to do this dot transform. Dot position is equal to, or we add to the position. And now we need to know how to talk to the position vector nicely. It is expecting a value of type vector 3. We can feed it a new element of type vector 3. You can see it's auto completing that. Vector 3s are initialized with an x, a y, and a z float component. Again, just like colors, these are floats. So, all we have to do now is decide which axis is the one we want to modify by pressing the L, or the left arrow. The other way that you can do this is this dot transform form dot position dot forward. How does it work again? Forward. Yeah. So this dot transform dot forward is already a vector 3 pointed in the direction of forward relative to the object. This is slightly different. If you add rotation, basically this is how you would do like tank controls. So this is relative positioning relative to the existing position of the game object. What I was doing before is absolute positioning relative to world space. So, new vector 3, I know I'm using a lot of words. Let's just move it a little bit in the x direction. In fact, probably a little bit less than that. The thing is, if you put a 1 in here, it will move, going back to Unity, yes, thank you. Like, where's my thing? Oh, it's still running. In Unity, 1 is one of these grid lines. So if you're moving one of those per frame, that is exceptionally fast. So, and we're not like moving the camera yet either, so, you know. There, stop it. There we go. If we run it, and we press the left arrow key, what's happening? Nothing. What's the matter? Oh, what? Oh, user error. I was pressing the right arrow key instead of the left arrow key. So you can see that left is moving me right and right off the screen. So, when that happens, very simple, just insert a negative sign. Fixes the problem. Now, left moves you left, but right doesn't do anything. As an exercise for the viewer, please take the code that we've written so far and adapt it so that we implement the right arrow. I'll give you a few minutes. That's someone's ID tag. That should be getting velocity now, actually. Put their key on that. Thank goodness. Nobody is allowed to impersonate professors with ID tags that they find laying around. It's against the terms of service. Question? Those will have floats. And you should initialize them to 0. Like it's that problem that we were having earlier, right? If the container is an integer and you're adding like a small decimal to it, that change will be lost every time because it's an integer. So that's why it won't do it.
This is a question. I noticed that your colors actually do much slower to method the 0.1f, if you make that a bit smaller, it will, like maybe half the size. The other thing that you can do is you can expose that as a variable so that you can modify from the interface. I'm good.
Change it to.
Sorry. Real close because my old man eyes. Well, I mean, you're adding 0, so of course nothing's happening. You can also expose the speed as a variable up here, which allows you to like control it. Like encoding generally behave doing this, like hard coding values like that, because that means if you want the speed to ever change, and like that's exactly the sort of thing you would tweak to improve how the game feels. You have to like modify it in the code every single time, right? Whereas if you put it in a variable, it's nice, less to work with. But you know, I'm not expecting things to go right perfect. I'm just like you. So that's the work too. No. It's really I was just checking to make sure we did actually cover everything that you need to do in lab 1, and we did. Obviously, you can extend this to the other directions as well, come forward, come back. You can hook other buttons up to rotation as well. But you want to do jumping,
What is that?
like making him jump. Okay, here we go. So, jumping will require the physics engine. So, and I only have 9 minutes, so this is the speed run version. Create our game object, 3D object, plane. Let's put a plane underneath him. Right. This guy needs a rigid body. Rigid body, there we go. So, if input dot get key down, key code dot space for the space bar, this dot get component rigid body dot add force. Add force is the best of all the methods. Add force will also require a rigid body. Oh, sorry. There you go. It'll also require a vector 3. So add a new vector 3. It requires a much larger number than the stuff we've been doing before. Force, you should be thinking in thousands rather than in like thousands, you know, or hundredths. So if we add 0 in the x direction, 0 in the y direction, and 1,000 in the z direction, which, wait, no, it would be y. Y is up, z is like forward and backward. At least by default. There we go. Save, save, save. Let's see how it runs. Whee! Bonk. So maybe that's a bit too much force. Or what we could do is we could just increase the mass of the object. Make it about 5 times heavier. Boop. Boop. There we go. Now, here's the problem, right? I've got infinite double jumps. And also, did you notice how it kind of, oh, by the way, the plane is here, it's just invisible because you're viewing it from the side. If I turn the camera to perspective mode, that should fix it. There you go. Perspective mode on the camera fixes that. So, if you'll notice, if you're traveling fast enough, he kind of clips through the plane a bit. See how he kind of bounces down? He's not actually supposed to do that. So, the way that you fix it, interpolate, yes, interpolate collision detection continuous. And it doesn't do it anymore. You see, that's that thing that we were talking about earlier in the other class, like 1 week ago exactly. So, yes, jumping. So, do you want to see how to prevent infinite double jumping? So in the code, what you need to do is you need to add a variable, public bool jump state, or perhaps can jump, which is initially set to true. instead of just modifying, just adding the force, we are adding the force and setting can jump to false. Now, if this is all we do, you get one jump and that's it. Just like those levels after the main game in Celeste, if you played that one, where they start to clamp down on the number of jumps you can do. I didn't care for it. It was on sale, I bought it, I played it, I didn't care for it. So what we need to do is we need to set it up so that when it hits the ground, it resets can jump. We have another one for this. Private void on collision enter. Can jump equals true. So this method, it's going to be plaguing me all semester. On collision enter is a method which activates when this thing hits another thing. This is a reference to the thing it hit. Let's not worry about that for now. When it hits something, can jump is set back to true. Save. So let's try it. Put my camera back in. Effective mode. Oh, and didn't modify mask. Capsule. Mass. Let's make it 3. So jumping still works. Oh, come on. Didn't work, sorry. Let's see. Okay. Main camera is in perspective. Capsules. Mass is 2. Play. Spacebar. Still. Where's the script? Oh! Yes, right. I forgot a part. So, input.getKeyDown, keycode.space. And can jump. If you don't put it in, it doesn't read your mind, right? If you're going to use the variable, if you're going to make the variable, you got to use the variable in order for it to do anything. So that little bit means that can jump must be true to enter this if statement. Save. And there you go. You can hammer that spacebar as much as you want. You only get one jump. Now, this still isn't ideal because the way it's set up now, if our little guy here hits anything, that resets his jump counter. So if he hits a wall, he can wall jump. He doesn't have to be against the wall to wall jump. He can kind of hit the wall, bounce off, and then jump from here, you know. If he hits a ceiling, he can jump again. In theory, it's possible to as written, it's possible if you hit a ceiling, you can keep bouncing yourself along the ceiling until you get to the end of the ceiling, and then bounce yourself up onto the geometry, keep going. But, you know, we're to the point where this is a game that could be a game, you know? There are games with mechanics like that. One wonders when a game has mechanics like that. Did they just half program the jump system? Was that's fun, and then they just went with it? Who knows? You know? But yeah. Any questions? Shall we get the heck out of here then? will release it on the day. It's too simple to release ahead of time, otherwise you'll just complete it in 5 seconds, and then I'll have nothing to do for that class. Yes?
I have a general question. So we have another class in this room at 7, so we have an hour break. Do you know if we're allowed to stay in this room? I know last time, like,
If there's nobody in this room, then yeah, you're like,
Okay,
it's
they
kind
won't
of
make
an-
it cleaner or anything?
they clean the rooms on weekends or at night, I'm pretty sure. Like, so long as classes can't be held, they won't come in, they won't.
They cleaned it between the classes last week.
Oh, did they?
Yeah.
Oh,
I think maybe they knew that there wasn't a class in here in that hour.
did they tell you, did they kick you out last time?
I didn't stay in, I just, when I came back, they
What will probably happen is like, if you folks stay in the room, they'll see there's people in the room, and they won't come in clean. But, you know, they are also human beings. You could ask them what the cleaning routine is, and whether you could ask them if they want to out or whatever, but like in general, if a classroom is not in use, it's kind of fine to be in there, as long as like, you look like you're working. Like it's a computer lab, don't bring food in, okay? If you want to go get dinner, then you should go get dinner. That's, but otherwise, yeah, there's no problem. Question?
Is there a chance you could share the code that you use for this script?
In progress.
I was trying to, there's like a media section to your campus.
Ignore it.
Yeah, you can't upload these guys.
The Canvas shell which I inherited was like all junked up with like all kinds of stuff from the pandemic and have never been unpandemicked. So it's entirely possible that there's some legacy stuff in there that I haven't seen and modified yet. Because like there's quite a lot on the Canvas shell for this course relative to other courses actually. So yeah, just do as I say, and if you have a question, ask me. When I have code, my tendency is to just post an announcement with the code. Today's code. Boop. I think you can even like embed it as code somehow. Format? Where was it?
Under subscript.
Subscript. Code. Ah, there it is. Thank you. Boop. So there you go.
Easy to read.
Yeah, so code is usually done in what are called proportional fonts, where every character takes up the same amount of space regardless as to whether it's like just a space or anything, and that way you keep everything kind of aligned. So, very nice. Monospaced fonts. This topic is closed for comments, as is my class. Thank you and good night.